Quick one, nothing here is financial advice. It's for entertainment and educational purposes only. Always do your own research or speak to a financial advisor before making any investment decisions. Enjoy the episode and like and subscribe.
GM, welcome back to the channel. In this one, we find ourselves at the intersection of blockchain and AI with GenLayer. So I'm going to break this one down. Quick TLDR. GenLayer is building, as they state, the first intelligent blockchain. So this means they're going to be utilizing AI to further the capabilities of smart contracts with what they call intelligent contracts. So by integrating with large language models, LLMs, it allows GenLayer's contracts to perform greater tasks than your basic transactions. So these contracts will be able to make decisions, process real-time information, and be highly dynamic with their outputs. And further to this, they won't be processing just your basic code. They can now process natural language as well. So opening this design space up very wide. This also removes the oracle from the smart contract equation, as they can use the LLMs to bring off-chain data on-chain. They have a direct internet feed. So a super interesting one. Any devs out there, check out the simulator in the top right-hand corner of the website. So an introduction to intelligent contracts here. We'll break this down in a bit more depth, but as you can see, the main talking points in here, these intelligent contracts allow for internet connectivity, something that hasn't previously been enabled within the blockchain landscape. Remember, blockchain don't typically connect to the internet. Their contracts will be able to process natural language, which will inherently make complex and subjective decisions. And this just changes up the design space for completely new applications and primitives to be born. So as you're probably aware, there's more L2s than we know what to do with, yet we haven't really seen many step changes. We've seen incremental changes with various blockchains, just small tweaks here and there. But what is the potential step change? And of course, it must be AI here. AI is such a transformative technology. So GenLayer here are taking us into the next level, into this new step change, and utilizing LLMs and artificial intelligence to move us from the world of black and white with code to one where we can use natural language to define a lot more and get more varied outputs. So here is where AI sits at the heart of their consensus methods. It's called optimistic democracy. We'll break this one down, but very interesting stuff being built here. So on screen, we have a brief history of contracts. So the kind of old way that's out there, regular law and those processes. Then in the early 1990s, Nick Szabo came out with the idea of smart contracts. These were self-enforcing contracts, which created a step change from the more regular law-based contracts. Then in 2013, Vitalik Buterin, founder of Ethereum, brought smart contracts to the Ethereum blockchain. But since then, smart contracts haven't gotten any smarter until now with intelligent contracts with GenLayer in the year 2024 here. Now you can see from the diagram on screen, there are some additional benefits. You have these contracts directly accessing the internet. They have the best of the previous both worlds, utilizing natural language and codes, and are future-proofed as well, as the infrastructure here will develop as AI develops. And so this future-proofs itself somewhat. Now, in terms of one of the founders, been listening to a few podcasts of Albert Castellana, CEO, and he's previously worked on prominent protocols such as NEM. You may remember that one from many cycles back, even Radix, and was also the CEO of Stakehound, the LST provider. So this guy is one of the OGs in the crypto industry, now pushing forward with what's possible with smart contracts becoming intelligent contracts. So if we just think about a basic smart contract and the kind of if-then outputs, they're deterministic. This means if you have input A, output will be B, and no matter how many times you run it, it's going to come out with the same output each and every single time. This is kind of the original vending machine analogy. You put your money in, it gives you the selected product you choose and any change due to you, but your coins remain protected inside that machine at all times. But as blockchains are isolated systems, in order to utilize off-chain data, we have to use oracles. Think about it, the vending machine can't process data outside of itself. And so we utilize an oracle to bring the off-chain data on-chain. Issues here reliance of the oracle. Maybe it's a third-party oracle, has some centralization risk. There's also many potential attack vectors with that. And also feeds are typically quite expensive. And so you have a limitation on the amount of feeds that are possible to you on chain. So the idea here is that the smart contracts are potentially the reason why we're seeing a bit of stagnation and not a lot of progress when it comes to blockchain tech and the applications available to us. But intelligent contracts really are that step change, because we're plugging into the likes of your LLMs, OpenAIs, your Llamas, your Claudes, etc. So intelligent contracts can do anything that a normal smart contract can, but they have that additional capacity with the internet connectivity and utilize these LLMs. This is because each of the validators in this network is connected to a different LLM out there. These contracts also utilize natural language, so you don't have to code to create an input. You can use plain old English. And then these AI models will access the internet to make complex decisions for you in a decentralized manner. This means that we have non-deterministic intelligent contracts. And non-deterministic just means that you can produce different results from the same input. So you could have the same input goes to those different LLMs, and they could each have a different output. So essentially, this is enabling a new smart contract logic not possible with the current infrastructure out there. As you can see, this would remove the need for oracles as the LLMs can use the web. And the AI here becomes an active participant in the network, making informed decisions based on real-time data and parameters set by the developers. So it is truly intelligent. Now, I think this makes quite a lot of sense because the real world is non-deterministic. So if we want to use blockchain in our everyday life, the blockchain therefore must have to be able to handle this non-deterministic data and deal with varied inputs and outputs. Therefore, it makes sense we need a new architecture, and this is what's proposed here with these intelligent contracts from GenLayer. So with this new way of doing things, we need a new virtual machine. And here we have the GenVM, the Gen virtual machine. As you can see on screen here, we have access via these LLMs to search the internet and the ability for the GenLayer and the GenVM to understand processes and prompts. So this execution environment can execute actual instructions. So the example on screen here, search online and find out who is president of the United States of America. This kind of task shows you that the GenVM is able to execute instructions. One of the differentiators of GenVM versus, say, the EVM, this GenVM updates the state of the network every transaction. Unlike a typical blockchain that updates every block, and within a block you would have many different transactions, this does it on a transaction basis. So the focus of the network is approving transactions. Developers will write their intelligent contracts in Python. Python is used in the machine learning world. It's an AI accepted programming language and is used by like roughly a third of all developers, whereas we have like Solidity, which is used by less than 1%. So again, opening the design space up for even more devs. The GenVM also taps into both open and closed source LLMs. So this gives a more diverse base of LLMs. And as we've seen, and you're probably aware of, some of these LLMs seem to have biases in specific areas. So you wouldn't want to be utilizing just one or two. You want to have that diversity of output from tapping into many different ones. Hence, each of the validators on this network is connected to a different LLM. So by integrating with AI at the consensus layer, as AI makes improvements, this network also improves with it. So this is a blockchain that will truly future-proof itself by being there at the forefront of what's happening with these large language models. So optimistic democracy is the secret sauce here, and this is the mechanism powering GenLayer, ensuring that validators reach agreement on the network state. And it's called optimistic democracy as not every validator is required to validate each transaction. So a transaction flow on this network, you have your validators here. You'll have a set typically between say 100 and 1,000 different validators. As mentioned, each of them connected to a different LLM for diversity, and each of them is also staking the Gen token. So once a transaction comes in, a leader is selected. So one leader, and this will then go out onto the internet, do its thing. The LLM in question will obviously come back with an answer to the various inputs and propose that to the network. At the same time, a subset of 5 validators are also randomly selected, and these will do the same. They'll go out, use their resource, and come back with an output to the various inputs. And what they're going to do is check their answer versus the leader's answer. If then the majority, because we have an odd number here, so we'll always have a majority either way, if they agree, the transaction will become valid and we get consensus on said transaction and it gets submitted to the chain. If there is disagreement versus the lead validator, or if someone wants to appeal, then we go to the appeals process, which we'll show you on the next slide. So you can see that this system is essentially aggregating the answers of various LLMs, kind of wisdom of the crowd. Multiple validators, i.e. LLMs, agree on said transaction, and so you get a secure, reliable result. So dealing with non-deterministic outcomes here, we have the equivalence principle, because input A is going to get output B, C through Z potentially. And through this principle, outcomes that vary may be considered equal. And this does put a bit of power in the developer's hand of the various applications being built. There's 2 different types of equivalence principle here, comparative. So this is more of a quantitative stance, i.e. you would put in a margin for error. So if your input was how many followers does Ansem have, maybe you would have a 2% margin for error. Lead validator goes out, proposes the answer, say it's 300,000. And as long as the other 5 validators come back and they've got an answer within 2% of that, then under the equivalence principle, those answers are deemed the same. And so you would have a successful transaction. But then we have more complex stuff as well. So non-comparative. So this is for validators assessing the accuracy of a leader's result against criteria defined by the equivalence principle. So this is for more qualitative outputs. So if you propose the input here, does the United Kingdom have the best food? That is, of course, subjective. But this principle allows the developers to define what is an acceptable answer for their various use case. So there would be tweaking of parameters, if you will. So what if we have disagreement between validators, or an external party wants to appeal a transaction as they think it is incorrect? Well, transactions on GenLayer are not finalized until the appeal process has passed without any challenge. This gives a finality window for stakeholders to assess and raise concerns around transactions if necessary. So as we saw previously, per transaction, typically you'll get 1 lead validator and then you would have 5 validators checking that work. But if there is an appeal, each round, a new validator is selected, plus they double the validator set. And this will occur for each round where there is an appeal or a challenge. So this could scale to decision 1, 2 through 10. And each time we have that incremental change, additional lead validator and a doubling of the other validators. Then if you've got an app with a specific use case that you want a lot more accuracy, or you want a bigger kind of jury panel to decide whether it's accurate or not, you can pay higher gas for, say, a specific transaction to ensure you have more validators looking at your particular transaction. And for those who are appealing a transaction, they must post a bond in the Gen token. And if their appeal is successful, they'll have that bond refunded to them. But if it is declined, they will lose said bond. So GenLayer has a delegated proof of stake network. This means that as token holders, we can come and delegate to a validator. As mentioned previously, each of the validators is connected to an LLM, and they will also be staking tokens as part of their role. The validators themselves will be rewarded for correctness and penalized for incorrect outputs. So this is part of that crypto economic security. And as they validate transactions, they're getting rewarded for this in Gen tokens, and users who are staking also likewise will get rewards in the token as well. Then the main token use cases, the Gen token is the gas token of the network. Validator rewards via staking and penalties via slashing, also taken in Gen. It's used for bonding for the appeals process, as we've just gone through, and it's used for spam prevention on the network. As yet, we don't have the full tokenomics around this. This is still very early days, but I'm sure we'll dig into that once that data becomes live. So thinking about the potential use cases of this, the design space really opens up massively once you have that internet connection and the use of AI via those LLMs at the consensus layer of the network. So this was proposed by them. What would you build on the world's first intelligent blockchain? Most of the results coming back are for prediction markets and fully autonomous DAOs. So some of the use cases, these are just 4 to think about here. But if we just think of prediction markets first and foremost, we know Polymarket is probably one of the standout applications of this cycle, but they do have human interaction and intervention within Polymarket, as I believe they use UMA for their decision making, which is, I think, a group of humans who make the final decisions. This, of course, will be highly expensive, paying for people's time, and probably quite a slow process. So imagine having a prediction market without human intervention, without human biases, and also without that human cost. It would be a lot cheaper. You would utilize in this scenario the LLMs to monitor maybe major news sites for sports results or outcomes of certain events, aggregate those between the different LLMs and come up with the correct results very quickly. Then I'm sure you've heard of DAOs, decentralized autonomous organizations. These popped off a lot last cycle, but they are kind of rife with a lot of governance theatrics, and typically you just have a multi-sig with X number of people on it making the decisions as they follow along with what happens on a snapshot page. But imagine if you utilize AI, you could create an AI-powered DAO. You would set the constitution, the rules, what you want the AI to defend as said rules, and what kind of outcomes you're looking for. Are you looking for the best ROI for the DAO? The AI connected to the internet, the LLM, can therefore analyze market conditions and take the best course of action as per the constitution that was initially created. And I'm sure this autonomous DAO conversation maybe even spills into autonomous government conversations in the future. And then if we think about perpetuals markets, why can't we trade the price of, say, Pokemon cards directly on chain? It's primarily due to the fact there isn't an oracle providing this data feed. It would probably be very expensive, but utilizing the LLMs, I'm sure we could do that. So this just opens up a huge design space. And to be honest with you, it opens up Pandora's box. So this does seem to be that step change for the next evolution of the blockchain space, as we can create new primitives that are only possible if we have that internet connection. So GenLayer has raised 7.5 million from some notable names in the industry, such as Arrington Capital, even the Maelstrom Fund of Arthur Hayes, and they're bringing a very fresh approach and a futuristic approach to the blockchain architecture here. Now they are aiming for a testnet by the end of this year and thus a mainnet in 2025. They have the developer simulator, top right hand corner of the screen. And to keep up to date with this one, you want to be following them on socials, dive into their Discord server, and stay tuned for what is to come, because this one is a very exciting design space that is being opened up here with the use of LLMs. So we hope you enjoyed this one. Subscribe if you're new. Peace.